What was once hidden is now visible, thanks to the Webb's infrared vision. A glowing wonder is emerging from chaotic dust swirls that will last millions or even billions of years. The James Webb Space Telescope has captured the unique moment of a star being born, and we are there live as the birth of the star unfolds in the midst of a dense cloud of gas and dust located above 450 light-years away in the constellation Taurus. The Herbig-Haro Object 30 is embedded in a dark cloud and shows us a young star in a protoplanetary disk. Being able to witness the birth of the star H30 live and in sharp focus is another stroke of genius from the best telescope ever. James Webb is constantly treating us to the latest and most exciting images from space. We have the new infrared technology to thank for the fact that we can see the processes in the dark cloud called LDN 1551 in such detail for the first time. Unlike Hubble, Webb captures light waves in the infrared range. These waves penetrate even cosmic dust and dense cosmic clouds like LDN 1551. Thanks to the new technology, astronomers can use an X-ray view to look directly into the cloud and thus witness the processes almost up close. Dense clouds of gas and dust are the birthplaces of many stars in the universe. Did you know that our sun is nothing more than a bit of condensed dust? Through a fantastic interplay of gas, dust, and movement, a new star gradually forms inside dense clouds. Researchers call the nebulous formations around young stars Herbig-Haro objects. They are formed when the gas from the young star encounters material in the surrounding dust cloud. HH objects are usually located near protostars and are aligned along an axis of bipolar flows called jets. Jets are blatant objects that race through space at speeds of hundreds of kilometers per second, generating extreme radiation and heat. Another side effect is the infrared radiation that the James Webb Telescope records. HH30 shows us split jets shooting out into space from the interior of the protostar. Hubble has already observed this star-forming region, but the dense nebula cloud hid a large part of the true processes inside. Webb's images provide more sharpness and detail. These further aspects, now visible for the first time, provide scientists with more important information about the birth of a star. In the image now published by NASA, we see the protoplanetary disk, an ejection of gas and dust, and a narrow jet shooting up from the cloud. Star bursts are events that take tens to hundreds of thousands of years. Years after the star has formed, inside the remnants of dust and gas, planets give rise. Our solar system looks similar 4.5 billion years ago. The clouds, called Herbig-Haro objects, with the activity of the jets, usually develop over the course of a few millennia. The processes inside the cloud are among the most fascinating in the universe. H30 is a hungry baby. What do you think about when you see images like these? That baby stars might be similar to humans, or where the mother and father of such giants might be. These are exciting questions, and in fact, even rational researchers often find themselves making such comparisons. The young star HH30 has often been referred to as the hungry baby. Like a newborn baby, it is constantly growing and devouring incredible amounts of material from its surroundings. HH30 is quite impetuous, and instead of milk, this young star feeds on gas and dust. The birth of a star is a cosmic spectacle that takes hundreds of thousands of years. It all begins in a dense cloud of gas and dust. A disturbance, such as a nearby supernova or a collision between two gas clouds, causes the material to contract. Then gravity takes over. The ball of gas continues to compress, becoming hotter and rotating faster. But not all of the material falls directly onto the growing protostar. Some of it gathers a flat disk around it. Planets can later form in the protoplanetary disk. While the star continues to grow, the planets are left with practically only what the hungry baby star leaves over. And it's not impossible for the star itself to swallow a young planet, just like a baby drinking too hastily and spitting out some of the milk. The protostar cannot absorb everything at once. The excess material is hurled into space along the rotation axis. This is how the jets are created, shooting into space at speeds of up to 700,000 kilometers per hour. These powerful gas streams collide with the surrounding medium, creating shock waves that make the entire region glow in a fantastic way. Over time, the young star becomes more stable. The core gets hot enough to fuse hydrogen into helium, the final sign that the star has grown up. The turbulence subsides, the jets fade, and a bright new celestial body remains. Now is the time for planets. When the star has entered its resting phase, they can develop more undisturbed. They absorb the remaining materials from the protoplanetary disk and slowly form around the constantly glowing star. HH30's mysterious spiral patterns reveal incredible things. While the James Webb Space Telescope was studying the young star HH30, astronomers noticed a mysterious detail. Spiral structures in the protoplanetary disk provided clues to incredible processes. These cosmic spirals are more than just a beautiful phenomenon. They could provide crucial clues as to how planets form and what forces are at work in the early stages of a star system. Scientists at the University of Tokyo, led by Dr. Ryo Tazaki, have proposed 3 possible explanations for this intriguing pattern. 1. Wobbling jet. Protostars like HH30 are not static entities. As they grow, they eject excess material into space in the form of 2 opposing jets. If the jet wobbles or fluctuates slightly, it could influence the gas disk and create the observed spirals. 2. A hidden companion star. Some stars are born not alone but in multiple systems. If HH30 has a previously undetected companion, its gravitational force could distort the dust disk and set it in motion, much like the moon affects the tides on Earth. 3. A passing star. Around 1,000 years ago, a foreign star may have passed very close to H30. Its gravity would then have left long-term disturbances in the disk, which are visible today. Spiral patterns. Such encounters would be no exception in the dense star-forming region of the constellation Taurus. But why are these spirals so important? Scientists consider the discovery of these spiral patterns to be very significant. They could provide the key to the formation of planets, as they influence the movement of gas and dust within the disk. These spiral condensations could form the material accumulations that then become planetesimals, the precursors of planets. Similar spiral patterns have already been discovered around other young stars, suggesting that this is a common phenomenon in star-forming regions. When the universe was created in the Big Bang 13.8 billion years ago, it was theoretically a hot, dense soup of energy and particles. For a long time, in the first 100,000 years after this massive event, matter began to collect through gravity from initial quantum fluctuations. The first gas clouds formed, which condensed into the first stars and galaxies. The process we observe today in HH30 is a miniature version of what happened in the early universe on a gigantic scale. The mysterious spirals in the protoplanetary disk discovered by James Webb could be a model for the formation of much larger structures. Spiral patterns are considered a key to the divide blueprint. We see them everywhere, from the spiral arms of our Milky Way to the vast filaments of galaxies that crisscross the universe. Spiral patterns can be seen wherever matter accumulates, where gas flows organize, and where gravity sets matter in motion. A particularly fascinating aspect is that similar mechanisms apply not only to stars, but also to entire galaxies. Large galaxy clusters may be formed by the same forces that we observe on a small scale. These similarities allow scientists to transfer knowledge from small scales to large structures, but that's not all. The new findings could also help us to better understand the development of life. Stars like HH30 are not only energy suppliers. They are important crucibles of the elements. In their hot cores, nuclear fusion produces heavy elements that make up planets, oceans, and ultimately living organisms. Every carbon atom that lives in our bodies today was once formed in the interior of a distant star. The James Webb observations not only show us the past of our own solar system, they give us a glimpse of the cosmic symphony of creation that began billions of years ago and continues to this day. Webb continues to point its golden observation mirrors into the universe every day, and each new discovery brings us a step closer to the ultimate understanding of where we came from. Click the subscribe button now. There are more exciting videos available.